have one announcement for you.
Yeah, go.
Sorry.
Whatever.
This Cameron from helps run CodeStop. He's going to do a quick little announcement.
Yeah, so real quick, I don't think I've met everyone here, but my name is Cameron Presley. I'm a software developer here in Knoxville, but also I'm director of speaker relations for this small little conference here called CodeStop. You've heard of us. And so I just want to take a couple minutes to let you know that call for proposals have opened up. And so one thing I've heard the last couple of years is that, hey, Cameron, we need more content on X, whether that be, most of the time it's something not .NET, which is great, but Python is usually one that comes up a lot. So this is me telling you, if you want more Python content at CodeStop, for the love of God, submit some. Or convince other people you know to submit some. So Gavin and I was actually having a conversation in the KnoxPy Slack, and so usually when someone submits a talk, a voting process happens and votes happen, and a lot of people think wherever votes happen, that's what gets in. Totally not true. All the voting does is it kind of tells us what trends, what are things people are interested in. Based on that, that helps guide us. I'm going to tell you, someone who makes those decisions, I'm always favoring people that are local and who are new to speaking. So, like I always set aside so many slots for that. So, if you've always wanted to speak at a conference and never had the chance, this is a really good chance time to do that. And if there's someone that maybe local in Knoxville or is in Nashville or something that you really want to see them come talk, tell them to submit because that helps me. Because a lot of the times when I look at and whatnot, I make decisions because it's like, oh, there's a lot of votes with like this technology, but there's only 2 talks, so both those come in. And then when it comes time to conference, they go, well, this is really cool. Why were there only 2 talks? Well, there was only 2 ever submitted, so I took all I could. So if you could help me with that, help me help you. You want to see more Python? Try to convince people to submit more Python talks. If you have any questions, concerns, or complaints, I'm on Twitter at @Cameron on the KnoxDev Slack channel, I'm there, Cameron Presley, and there's a CodeStop channel. Feel free to drop a question there. But yeah, so I want more Python talks. I want to have a really hard problem to solve this year. To make my job hard, okay?
Do you know if you haven't submitted yet?
I don't think so. I've not went, I know we've had about 80 abstracts submitted so far, but I've not went. Yeah, so fun fact on conferences, the first week, crap ton of submissions, and the last week of the CFP, crap ton of submissions, and very few in between. So yeah, I think we had like 30 on the first day, 30 or 40. And as people are realizing and the emails go out and people are telling their friends like, hey, CFP's open up, that's when it all comes through. But I don't recall seeing any Python talks specifically. At least if they were Python, it wasn't blatantly obvious in the title.
Is somebody here to commit to submit a Python talk?
When's the deadline?
It's like November 9th, something like that. It's like the first, second week of November. That's when CFP closes. There are some,
Just thinking about it. I think that's 2 talks right there.
yeah, no. My hope is to have a full Python track. Is so that every time slot there's something Python or close to Python. Maybe it's a data science talk using Python, but I want something there, right? And I'm going to be honest, intro talks are cool. I want to see some of the cool crazy shit you all do. Right? I'm in the .NET world, so I deal with a lot of line of business stuff all day long. I want to see some of the cooler stuff that you all do. Okay? Any questions for me immediately? Great.
CodeStop.org and sign up there.
If you go to our Twitter handle, like our Twitter page, you'll see it. But I think we're using Sessionize. So if you do sessionize.com/codestop-2019, you'll get there. As a speaker, you get 3 tickets to the conference, obviously, a pretty cool speaker gift, and the speaker dinner the night before where you get to chat and hang out with some pretty cool people the night before. So if you've always wanted to have that really like deep one-on-one conversation with Doug Stearns over some cool stuff he's working on, this could be your chance.
I was a first-time speaker at CodeStop last year. And I enjoyed it. Thought it was well worth it.
And food's decent.
Food was great.
Yeah.
a speaker dinner up in Sunsphere, and you get to meet a lot of interesting people that come in from out of town. Not just area people, but some people come in from New York, California, or wherever.
Yeah, so like last year we had Jeremy Clark. I'm sorry, I'm calling off people that were from the .NET world. That's people know, but we had Jeremy Clark from California. So I think maybe Washington State. We had some people from Washington State specifically. We had some people coming down from Florida. Some people coming up north. You mentioned New York. I'm thinking like we had some people from Indiana, Illinois, that area specifically. So yeah, we have a decent group of people. But CodeStock's always been by the community for the community. So I want to see a lot more of our local people going to right?
Take submissions for keynote speakers.
So the keynote, I don't get to control that. The board actually makes the decision on who, like they reach out to a specific person for keynote. All I know about that is that someone's already been decided for that. However, if there's someone you think would do a really fast job on a keynote, please let me know because I don't know if they've done a closing keynote selection yet. So last year, you may remember we had Paige Bailey do the opening keynote, but the very last day, the closing was David Neal. Well, I was the one who suggested David last year. Like he's local and he does an awesome job. We should have him. So you got someone in mind for a closing keynote? Let me know.
They're not local.
So Paige definitely isn't local either. I couldn't tell you that. I am close. Yeah. Any other questions?
If not Python, what else should presentation about?
Submit something that you're passionate about. Something that you feel like you go talk to someone about for about a good solid 45, 50 minutes.
No, I was just wondering if there are any like, or if your data shows anything besides Python.
Sorry, and I apologize for you, my man, because I'm totally stealing your spotlight here. It sucks. Historically, CodeStock's always been known as the .NET conference, and even though we've not been like sponsored by Microsoft in a couple of years now, it's really hard to shake that. So even last year, I think one of the guys like, well, there's too much .NET content, and I was like pulling my hair out from Jesus Christ. No, actually, I like weeded out 80% of it. Like, I'm doing all I can, but if the majority of your submissions are .NET, what can I do?
I don't know if .NET can plenty of options.
Yeah, so
The only reason I don't say
How I got into Python. I can't talk about it.
personally for me, I would love to see professional skill talks, Python, because we have a larger than I would expect community here. Yet I'm not seeing that reflected in CodeStock. We got to fix that a little bit. And so I know the .NET community, I know all that. That's well represented. What about everyone else? Like, I would love to see some Swift, iOS stuff. I know we have a community doing that here, but I don't really ever receive very many talks on that. So, Gavin, I know that may have tweaked your other interests.
We had a couple submissions this year. iOS. What's his name? Did all iOS stuff. Star.
He does iOS because he does like data Python stuff.
He also submitted Chalice.
Definitely not Doug then. Doug's usually only sends like forward. It's usually like Python and friend, like data science or machine learning or something. But regardless, keep that coming in. Unless there's any other questions, that's it for me. Well, I'm gonna get out of y'all's hair and let the real star take the stage here and do what he does best. So you're submitting this to CodeStock, right?
I can.
I mean,
you wouldn't like me if I did, though.
All I'm saying is this seems.
I won't be here.
So.
Yeah.
Moving to where?
Menlo Park. I'm
Okay.
going to work at Facebook.
Okay, that's cool. So you can't make the trip back down to Tennessee.
I'm leaving on the 5th, so
5th of
November.
You can't make a trip for a weekend back here in Knoxville.
No.
Sure?
I have to find a place to live out there. On the 9th, I hope to be signing a lease on some place.
Yeah, this is April.
Wait, you just said November 9th.
It's the closing for CFP.
Oh, okay.
No,
Okay.
the call for proposals closes in November. The conference itself is not till April. So
Okay.
it looks like you have a slide deck. And if I had to guess, I bet it's about 40 minutes in length.
Actually, it's really not. I think it's only like 7 slides, but I talk a lot, so it works.
Well, whatever works for you. But it seems like you look like someone who could fill a good 45-minute time slot. And I bet you're really good at answering questions.
Mm.
And I bet my age will be missing lots of so much.
Right.
And they'll be good Python with that too, so.
I'll be missing thunderstorms, if nothing else. Be like, man, I need to go back to Knoxville for thunder.
Just,
I'll think about it.
well, I've done my job then.
You got 2 commits. I'll commit to submitting one. That's the very right there.
So I think there's 12 sessions throughout all of CodeSock, so you need 8 more to have a Python track. Just saying.
Huh.
Thanks for letting me talk in front of you.
Yeah, sure.
Here. Thanks. Guys.
So is it viewable? Okay. Thought I'd make sure. Hopefully we haven't been like recording the whole time. Well, no, I guess Knox devs would want to hear about this stuff too. I take that back. Okay, so originally I was going to say this presentation is adapted from one I did for the AWS meetup a few weeks ago. But since I spent all my time working on the code and the demo and no time updating the slides, it's actually going to be basically the same presentation as what I gave to them talk-wise. But instead of ending at the talking, I'm actually going to go into the code because my goal with this presentation is to kind of talk about what OAuth is, like at the protocol level, describe how it works, and then I would actually like to go into the code and actually show you an implementation of OAuth in Python. I have, there are 3 components to OAuth. There's an authorization server, a resource server, and a client. And I've implemented from scratch the client and the resource server parts. The authorization server is where you have to like manage users and things and issue tokens, and I didn't want to do that. So we'll leave that to things like Okta and Google. But yeah, so we'll start with me. My name's Brian Burke. I work I'm a Linux or automation or cloud engineer at Discovery. I work for Andy. I used to work for UT. Never went to a football game. I don't have cable, so you know I'm not really getting into my employers very much. I mentioned this partly because I will be showing some code, and I like to compartmentalize my code, make simple solutions to simple problems, and then chain them together. You know, not necessarily with Unix pipes, but you know, in some form or fashion, put all the pieces together to solve complex problems. And in addition, I also tend to I like to automate things that no one else feels like they take the time to, or at least that's my impression. And just full disclosure, this talk is a little bit on AWS. I'm going to try to downplay what parts of that, but it will factor into some of my examples. But 2.5 years ago, I didn't know what AWS was, so yeah. So we'll start with OAuth2. It is an authorization protocol. Specifically, it's not authentication. It does not provide for how a user or a service or whatever gets authenticated, but once it's authenticated, it kind of describes how that service or user, in general, the client, is authorized to access resources. Resources could be data. It could be a service. It doesn't really matter. The protocol is very generic. It's meant to serve a lot of different use cases. In addition, partly because it's not authentication, it's not identity management. It's not. It doesn't manage users and groups. It doesn't know. Pure OAuth token really don't even know who you are. OAuth token won't have any personally identifying information in it. It'll just have basically a list of things you're allowed to access. And by holding that token, you're sort of presumed to be, you know, an owner of that token, or that it was given to you properly.
Question.
Yeah.
Would that be considered kind of like a bearer?
It is one type of bearer token authentication. There's more than just OAuth, or at least there's room for more than just OAuth, but it is a type of bearer token authentication.
Provide those authorizations to you.
Correct. Yeah, so again, it doesn't have any personally identifying information. So the fact that you hold the token is sufficient to say that you have access.
And if somebody else were to copy it,
then they would have the same level of access as you. So naturally, they need to be kept secret. Part of the OAuth2 specification by the RFCs say that the channels that go over have to be encrypted for exactly those sorts of reasons. So if you actually try to connect to anything over HTTP, a lot of, like, if you don't implement your own stuff, if you actually just use libraries that other people have written, a lot of it enforce that. Some of them have flags, some of them don't, that can say, no, I know it's okay that you're connecting back to a regular HTTP connection, it's okay. But most of them enforce that. So it is a requirement of the protocol. I mentioned several use cases. Those are several flows. There are different, the flows basically implement the different use cases that you run into. Again, there's like an implicit flow, which is primarily for like service accounts. There's authorization code flow, which is primarily for users. And then there's, I think it's, well, I think, I'm a little hazy on this one, but there's, I believe there's a third kind. Oh, sorry. There's implicit, authorization code, client credentials. Client credentials is the service account one. You basically hand a service account, for example, a private key, and it just gives the private key to the token endpoint and exchanges it for a token, and that's it. It's a pretty straightforward. It's a pretty straightforward authorization flow, or authorization flow. Anyway, there is a fourth kind, but it's deprecated, and that's basically it's more or less like basic authentication. You pass a username and password directly to the token endpoint and get a token. It is discouraged. And then on the Okta side, on the authorization server side, there's usually like a hybrid flow, which is basically authorization code and implicit, and that's so that you can do things like have dashboards of applications. So you just go to your dashboard, you log into your dashboard, and just click on an app in your dashboard, and you just get taken there. You don't have to go there to your app, then get redirected back to your dashboard, and then get redirected back to the app. So there's sort of a special situation for triggering the flow from the authorization server. So I mentioned that there are 3 components a minute ago. It's important to distinguish these because at least when I first learned about it, and I've known other people when they first learned about it, it can be confusing. The terminology is not always used in a way that is maybe consistent with how it's usually used. These terms are very specific to this protocol. And in particular, I think the client is the one that probably is the most confusing. And so we'll spend a minute on that. And that is that the client is the thing requesting resources from the resource server. And you have to think about it at that level of abstraction. So the client isn't even you if you're accessing a website. It's your browser. Your browser is the client. If you are accessing a completely like server-side web app, then the client is the same thing as the resource server. The client is the web app. The client is the thing getting your authorization code and exchanging it for a token and then doing things on your behalf. An example of that might be, again, since we're talking about AWS, I'll throw that one in there, like the AWS console. Not that it's using OAuth, I don't think, but if it were a console itself client, it reaches out to Amazon's authentication system or authorization system, would get the token, and it would use the token to access AWS services on your behalf. But it would be the console itself that's the client. You're not the client. And when you actually start reading about it, that distinction makes sense, and it will make the rest of OAuth make a lot more sense. So the second component is the resource server. That is the thing hosting the service or data or whatever, the resources you are trying to access. Generally speaking, the resources, if you are authorized to view or retrieve them, you are referred to as the resource owner. That being the person holding the token. You are the resource owner. In practice, obviously, that doesn't necessarily make sense. But if you think again about, or it gets hazy, right? Because if you're accessing, to use the AWS console as an example again, it's the thing holding the token. It's accessing services. The resource server is Amazon stuff, but the resources are effectively yours, right? It's your data in an S3 bucket. It's your instance in EC2. So the terminology gets a little strange, but generally speaking, if you're reading about OAuth and you see resource owner, it's referring to like you, the person actually acts like driving the authorization flow or driving the whole thing. Finally, there's the authorization server, which again is the thing that you actually somehow authenticate to. It's up to the authorization server to decide that, or whatever is hosting the authorization server. But once you are authenticated, the authorization server is the thing that issues you your code and or your token and or keys that sign the token and several other things. So the primary method, I don't think OAuth2 specifically requires JavaScript web tokens, but I've never seen an implementation that didn't use them. So I'm just going to say they use signed JavaScript web tokens. They can also be encrypted, but I also haven't seen that in practice. An interesting and unique property of OAuth2, or part of the protocol, is something that was not present in the first protocol and is not present in SAML and other things. And it's the concept of refresh tokens. If allowed and if requested, a refresh token can be exchanged for a new access token. So you can require a, say, user to interactively log in one time, and then as the tokens that get issued to them expire, you can use the refresh token to get a new one instead of redirecting them back to the login page and logging in again. Of course, your browser could cache some of that, so it might ease the burden, but the point of the refresh token is that if you're holding your tokens in a secure place, then it should be just fine to use those refresh tokens to get new access tokens. I think the last thing to mention about the protocol is the use of scopes. They're one of the primary mechanisms for determining authorizations. Scopes effectively map to claims. So when you request a token, you request certain scopes. Those scopes, if honored, if you're authorized to use all of those scopes, you'll get a token back with additional claims in the token that correspond to those scopes. You'll also get the scopes back if you want to use them directly. Scopes are themselves claims in your final token. And if you want me to stop and go into more detail on any of that, let me know. So then there's this thing called OpenID Connect, which is an additional protocol built on top, or it's an extension of the OAuth2 protocol. It uses tokens, just like OAuth2. It uses refresh tokens, it uses scopes, everything I've talked about, all of that's the same. The only differences, or the extension parts, are that, and for the record, I don't know much about this, but I know OpenID Connect specifies how authentication can occur. That's one of the extensions to OAuth. But the primary distinguishing feature is that OAuth2 is for authorizations. It is to indicate what a client is allowed to access on the resource server. OpenID Connect was designed to fill the use case of single sign-on. So OpenID Connect tokens are meant for signing on to services, not necessarily authorizing you on those services. The difference between the two in practice from me so far is very little, because if you can customize your tokens, you can effectively make authorization like OpenID tokens, and vice versa. You can make you can add personally identifying information into access tokens, but I think, again, that's kind of the point, or that's why it's an extension of OAuth 2, because it is exactly OAuth 2, but with extra stuff. And some of the extra stuff is your personally identifying information. So an OpenID token may have something like your email address or your username, along those lines. Okay, I said everything that was already on there. Sorry. So again, an example for using OpenID Connect would be like signing into Google. A use case for OAuth 2 would be accessing a file you own on Google. There's a lot of overlap there, but it's a slightly different use case. I kind of already talked about this, but again, client credentials is the flow where presumably a service account has some secret, probably a private key, for example, and that client can, in a completely non-interactive way, exchange that key with the token endpoint to get an access token. I guess that might be another difference in use case slightly. A client credential for a service account may not get an ID token, because the service account is effectively just acting on behalf of an application or something like that. The authorization code flow is the primary one that you'd be familiar with. It is, you go to log into a website or a service, and you click on the login button and you get redirected somewhere else. You get redirected to Facebook or Google or some proprietary sign-in page. Once you sign in, you get redirected back to the original service with your authorization code. Those authorization codes are typically only good for like 30 seconds, maybe 60 seconds. And so the client, whatever that is, has to reasonably quickly exchange that authorization code for a token. Once it has that token, again, for SaaS type services, it's probably your browser acting as the client. Your browser handles the redirections, but ultimately it's JavaScript running in your browser that will exchange your authorization code for a token, and then the JavaScript will store the token either in a cookie or in JavaScript local storage, or I guess those are the two primary ones. There are more steps to this because, again, the use case is I'm a human going to a service and I need to sign into the service. So that service has to redirect me to the authorization server. I have to, in some form or fashion, accept. I mean, that is part of the protocol where you get a page presented saying the resource server, is it the resource server? No, sorry. The client is requesting a token, and it's requesting a token for access to these things. Do you want to allow that to happen? You click allow, the token is, or the authorization code is issued, then your client can use the authorization code to exchange it for a token. That token is scoped to whatever you just allowed access to, and then the client from then on can use the token to actually access services and resources on your behalf. Again, because it is a human interacting with it, the authentication can be more flexible. So it's not just username and password, right? Like there can be MFA or security questions and answers or whatever. It doesn't, any of those other things that you've seen, like all of that can be there because there is a human sitting in front of it, typing things in or clicking on buttons. So all of that can go into the authentication. And I described that last bit. Like I said, there's an implicit flow, and honestly, I'm not 100% certain of how it works. I think, from my understanding, I believe what happens is there's no explicit step where you allow something. So you authenticate somewhere, and then in one step, you are redirected from that place to the resource server. And so there's no authorization code that gets issued in exchange for a token. There's also no, like I said, there's no prompt to say, do you want to allow this level of access? All of that's taken out for the implicit flow. But it does still use, but it still does not fall under the path of client credentials because you're not holding on to something like a private key that you're exchanging. So I guess the implicit flow is like a slightly shortened authorization code flow. And that's it. That's all I had for the actual slides on the presentation. Like I said, it's not very long. Let me see if I can. I at one point tried to make a little flow chart for an authorization code flow, but I don't think I ever finished it, but I'll check. I don't, in case it helps illustrate anything, but yeah, it was just describing the authorization code, but I'll still bring it up. Why not? So client for the authorization code goes to the resource server and requests access. The resource server says, hey, you're not authorized yet. You need to be authorized first. The resource server should, as part of its response, give some indication where it needs to go. Sends that back to the client. So it basically sends the redirect URL to the client. The client takes the redirect URL, goes over to the authorization server, authentic, and then actually this isn't. Then this is saying it immediately gets the token. It doesn't. It goes back to the client once more. The client goes out again to get the token with the authorization code, and then finally with the token, it makes the new request, the new authorized request to the resource server, which still doesn't have to work, but hopefully it will, because you could still have authorization to a service and try to access something that you're still not authorized for, even if you have a token. So anyway, so there's not much to see there. So probably way too small. So the next bit that I'm going to show is just going into the code, and I'll explain my use case here before I go into it. So right now, SAML is a type of authentication that's typically used for single sign-on. We use it at Discovery to sign into AWS, into the AWS console. The problem is that SAML's a little bit tricky. It's kind of heavyweight, and it doesn't work so well on a command line. You can make it work. We've seen it. This guy you've used it, right? Do you use the SAML? Didn't you guys write a custom wrapper around like the old Okta Java tool? Oh, really? Okay. So there are tools that exist to basically authenticate you to AWS using SAML, but I've seen several. None of them work very well. In particular, one of the things that for some reason they assume, is that you can, your credentials file that holds your API keys only exists for the purpose of accessing accounts that authenticate with SAML. So most tools just blow away your credentials file every time you run them, which is awesome. So we didn't use that, and in general, it's a little bit tricky to make work at the CLI level. In addition, I wanted to make use of these refresh tokens. So another problem with SAML was that when your session expires, you basically have to initiate the SAML flow again, which means authenticating to your identity provider again and all that. So I wanted a slightly friendlier tool to use to authenticate our stuff. Yes, the AWS SDKs and the AWS CLI tools wanted a way to authenticate once, and then I wanted to make use of the refresh token to automatically refresh your token every hour, say, and that would be non-interactive. That makes our identity provider the single source of truth. It means that we don't have to create IAM users in AWS, so there aren't so you don't have like a user account in AD or Okta and also a user account in AWS. It allows you to make use of roles directly. Yeah.
I wanted to ask about like refresh token. Do you have to refresh within a certain time interval? Like, what if you don't?
It's configurable, but the general design of access tokens and refresh tokens is your access token can be used many times within a well-defined interval of time, like an hour. But it can be used as many times as you want in that hour. And then when the hour is gone, it stops working. A refresh token, by contrast, is meant to be used only once to refresh your access token, but its time period can be much longer. So you have a time-limited token, and you have a use-limited token.
When you refresh, you also can.
Correct.
Okay. So you can't reuse the refresh token forever or every day for a month.
Right. Every time you use it, one use, and then you get a new one. So there's a continuous chain of refresh tokens that you're.
You can have an access token good for an hour, but a refresh token good for 30 days. Right. And that can keep you definitely. Right.
So I did mention Okta, and I will talk a little bit about it because I actually really like it. I've used it certainly directly to like AD or LDAP, and I've used Google's identity management, and it is good, and it has most of the same features that Okta does, but they're all in different places. So you manage users in one place in like the admin console, but then if you want to make like a new OAuth-based application, you have to go to the Google Developers Console and make it there and tie it back to your organization. And it probably needs to have someone just sort of look over the whole picture and kind of unify some things, but that's what Okta does. Okta has everything kind of in one place. And if anyone's in, and you can get free Okta accounts for testing purposes if you're interested. And so if anyone wants to, we can look a little bit specifically at Okta. But what was I going to say? So with Okta, it's configurable, and by default, your refresh token, the sort of continuous session of refresh tokens started by a single like authorization code flow is valid indefinitely. They never expire. But individual tokens expire after 7 days. So you have to be continuously using it, but as long as you're continuously using it, you never get prompted again. You never have to log in again. But if you were to like, take a few weeks off to like go on vacation or something and come back, you'd probably have to sign in again and initiate a new session. And so again, I wanted to make use of that with our tools, both to make Okta a single point of authority and to simplify the sign-in process and to reduce the number of user accounts we had floating around. So let's see. So we'll skip the demo part for just a second because that's a little bit higher level. Making it what? Sure. Is that visible to everyone? Okay. I'm using pipenv to manage this this project. Eventually, I'm probably going to turn all of this into a pip package, and I won't need this anymore. But for now, so first of all, so what this does, there are three tools. OctaAuth is the tool that initially authenticates you, and I'm going to show some of the code for that. It actually redirects you out to Okta. You sign in. It hosts a local host-only web server that you get redirected back to. It takes the authorization code, exchanges it for tokens, and writes your token to your home area. Okta Creds is a script that is actually meant to be used by AWS tools itself. So, no, not head. If you see this last bit, when specifying profiles with AWS, one of the options you can specify is a credential process. And it is some external tool that when you run it, all it has to do to succeed is it has to print out your API keys and one or two other pieces of information on standard out as a JSON encoded structure. And if you do that, you can plug it in as a credential process. So the second script actually parses the token that you get initially. It attempts to exchange it for API keys with AWS. If the token is expired, it uses the refresh token to get a new access token, and then it tries again. Finally, the print token is just a little tool I made to make it easier to see what was in the token. So apparently my token's valid. It won't let me print the library I'm using with JOTS won't let me actually even load it if it's not valid right now. So this is what my ID token looks like. I'm using this for single sign-on, so I'm using OpenID Connect. There's my free developer Okta account where I've been playing around with this. There's my email address that I'm using. Again, it has personally identifiable information. Some other interesting things to note in here are the subject. The subject in theory is the thing that is interested in using this token. It's the resource server. The subject, I believe, is more or less the resource server. Or maybe that's the audience. Those two get a little confusing to me. I should probably read up more on exactly what the difference is between the two. But actually, I think the subject stands in for the user. So for an OAuth token, it would still have a subject, and the subject would be something incomprehensible like that, that on the authorization server side, that maps back to me. On the resource server side, though, it has no idea what this means. It's identifying me for purposes of keeping a session or a local user database on the resource side. Think of it like a unique identifier for the user. So yeah, I think audience is actually like the resource server. Just some other things to note inside Okta's access tokens and OpenID tokens. And this is supported by AWS as well. These list all of these. Oh, by the way, I should say all of these things, all these keys in this dictionary are claims. Every one of these is a thing that the authorization server is asserting about the person holding this token. So AMR is a claim. Subject is a claim. Is a list of authentication methods used. So when I authenticated to get this token, I used MFA. I used a software key because I used my Authenticator app, not like a UB key or something. And I typed in my password. So you can use that on your resource server side for additional controls, like certain particular operations or data might not be available to you unless you use MFA. But you can check those in the claims. See, the time I authenticated, when it expires. I'm not sure what IAT is. Issued at? Issued at, oh, I guess the auth time is maybe the time you first authenticated, and then this is the time this specific token was issued, I'm guessing. Last is that you can do things, if your authorization server is hooked into your identity management, you probably have a list of groups that you're a member of, and you can map those groups into your token. So you can also do authorization or sign-on decisions based on groups. So I have at work, I have a proof of concept of Jenkins that I'm working on using OAuth. And so I created a group, and I'm mapping that in my token so I can play around with Jenkins, OAuth, and OpenID Connect capabilities. Oh, right, I know why this token's valid is because I refreshed it like just before the presentation started. And so you can see what it looks like, what a credential helper process looks like. Okay, it's actually using the cache credentials. This caches the API keys, so it doesn't call it every time, but let me remove. There we go. So it read my token, it assumed the role right then, and then this is the format expected by the credential helper process, including the expiration. Again, if I run it again, it just caches the credentials. So. Finally, though, if I were to delete the token altogether, actually, do I want to delete the token altogether? We're only 10 minutes out from a refresh. That's whatever. Now, presumably, these will throw all kinds of, exceptions. Okay, so to do the initial authentication, I didn't have to actually delete the token, but whatever. I just wanted to show you that it was gone. So again, this is written in Python. It starts up a Tornado asynchronous web server on localhost, and then I can connect to that. I go to my browser, I get redirected to Okta. I was actually already signed in. Here, let me sign out.
Is it really, I know there's Python standard library that actually open your web browser.
Is there?
Yeah.
Okay, I've tried to find it. I tried not to just print it out so that you had something. Like printing it out so you had something to click on was as close as I could get. I've seen it before. I know it exists, but I don't know how. I didn't want to make it like too specific to Mac OS and call out to like the open command. I wanted to make sure it would work elsewhere.
I know that people OAuth.
Right.
Somewhere in there they have browser.
So okay, so actually there is in some of the libraries referenced by Google, there is one that actually does open your browser for you, but it says all over the page, if you actually go to like the project page for that, don't use this library anymore, you should use this instead, and the new library doesn't have that feature. So I did find one library that does it, but since I was trying to build all this from scratch, I wanted to make sure I was using stuff that was up to date, not deprecated, whatever. All right, signing out of my developer account. Let's go ahead and just run this again. So I get redirected to Okta. For some reason, LastPass isn't filling in my information. I sign in, do my MFA. There we go. It's done. Done, and then I can print my token again, and there's my new token. It's almost identical to the other one though, so you know. Also run this one more time and make sure. Okay, well, it's still using the cache credentials. So anyway, I was going to talk a little bit about how I constructed the Okta auth script and why I used the Tornado web server. So here we get into the actual Python stuff. So I originally tried to do this with Flask, right? I knew Flask. Flask is super easy to use. Flask is also designed to be run in a synchronous manner. And once you start Flask, it's not designed to be just killed by the program. Whatever, I still went with it. What ended up happening was after you got redirected back to localhost and got your authorization code, it would take the code, exchange it for a token, and then write it onto a queue. You can still see a little bit of this here. This was a fun reason to play around with asynchronous stuff as well, which we can talk about a little bit about. But anyway, when this method gets invoked because Okta redirected back, it effectively gets the token by doing a post with with the authorization code it just received, the grant type, the original redirect URL, and the response includes the token. Escape. Where's? Oh, that's a package in the Tornado web server. Okay. So it just decodes the response body, and that is the token. We can look at that as well by right. I'm not in TMUX. So I cache some of the metadata that the authorization server provides, including the metadata URL, the issuer authorization endpoint, token endpoint, key endpoint, the grant type supported. There's authorization code, implicit, refresh token, password, client credentials. Here are the scopes that it supports, claims, different algorithms used to sign the tokens. This is the actual public key that signs the token. And then here's actually what you get from what I just showed you in the code when you decode that response body. You get an access token, which is this big long thing. Token type bearer, again, it's bearer token authentication, expires in 1 hour. These were the scopes I requested, or these were the scopes I requested when I requested the token. Here's my refresh token. And then here's my ID token. This is my OpenID Connect compatible token.
Any sort of error requesting scope that the authorizer can't authorize?
I'm trying to remember.
I think it's inside the ID token or the access token, it gives you the scopes it authorizes.
I was going to say, I think it returns the intersection of the scopes you requested with the scopes it's allowed to give you. So I don't think it fails necessarily, but I'm not 100% sure of that.
So is the natural interpretation of these scope lists that essentially implying that you have full access to all those scopes, like anything that requires just one of those?
Yeah, so they're additive. So again, with this type of thing where I'm using single sign-on, it's a little less clear because offline access, that's how you request a refresh token. That's how I request an OpenID token. And I also explicitly wanted to include the email because I want to use the email as my unique identifier. But if you looked at something like, the only other place I've really looked into this is with Google Cloud Platform. And if you look at the scopes they provide, the scopes are a list of HTTP style URIs. And it's like cloud.google.com/ storage.read or storage.readwrite or storage.admin. So they do URL parsing for their scopes, but yes, their scopes directly map to what you're allowed to access.
But if you think about like authorization on the law, right? The moderator's scope lets you delete comments, but an author's scope lets you create articles. Yeah, and an admin scope lets you change CSS. Yeah.
I was just wondering if there might be any confusion on the, I guess in this case, since they're additive, then an authorization server knows that if you have authorization, or if you have access to these scopes, X, Y, and Z, then it can.
The authorization server doesn't care.
Yeah, so
The
there.
authorization server just says, like, that person has these scopes. Returns that back to the application. The application.
Oh, okay.
Yeah, so if you notice that in my OpenID token here, I just changed the print token script real quick to print the access token as well. So this has a list of groups, has authentication mechanisms, but in the authorization token, it has the list of scopes requested. Because again, scopes are meant to be a claim as well. The authorization server granted these scopes to you. So you can use them directly as claims to validate a request. Let's see. All right, I was talking about the tornado versus Flask. So what I was running into is that when I got the code callback, tokens, the token to a queue, and then I'd write success back to the browser client, and then it would exit. And then the rest of the script would go on. It would write those tokens to disk. It does some validation on them actually. So after it gets the tokens, it actually loops through all the, because you can receive more than one public key from the authorization server. So it loops through the keys, checking each one to see which one actually signed the token. And if none of them sign it, it actually, it fails. But presumably one just signed the token. And but anyway, so it would do this. It would verify the token. It would create this configuration to write to this JSON file. It would dump it, and then it would exit. Problem is, all of that happened, and it still happened faster than Flask. Then it all happened in less time than it took Flask to take this return statement to write something back to the client and actually send it to the client. So what ended up happening was you'd click on the localhost URL, you'd go to it in your browser, you'd get redirected to Okta, you'd sign in, and then you'd see 500 internal server error. And just for usability, since there would probably be people who aren't super familiar with OAuth or Python or whatever using this, I didn't want them to see an internal server error. And so I originally tried, after getting the tokens right here, I tried to come up with some mechanism where I could immediately kill Flask or something, but that ends up, that does the same thing. It ends up dying before it finishes writing the request back to the client. So other than putting a sleep statement in to just sit there and wait for 10 seconds or something like that to make sure it finished, it just didn't seem like the best way to go about this. So what I actually did was I use the asynchronous web server, Tornado. It's kind of neat. It's not nearly as nice as Flask, but because it's asynchronous, only it kind of emulates multi-threaded code, but it's not actually multi-threaded. Things have to voluntarily give up their CPU time. They're not interrupted. So I just write this to a queue, and I effectively I don't interrupt the web server until it finishes writing that. Once it's done writing that, I basically come back here and I don't make any await calls from that point on. So the Tornado web server just never gets scheduled on CPU again. And just to fun little way to make use of asynchronous programming to like make sure the server had enough CPU time to write things back. It doesn't give up the CPU until it's done, and then I can just basically not allow it to be scheduled again. So that was kind of an interesting way to, I thought, to like make use of that. Real quick, this is what happens when you request the root. You just get redirected to Okta. This is the metadata endpoint. This is the callback that you have to specify when you request the authorization code and the token. Again, you have to be listening on localhost. And again, when I was using OAuth frameworks, the fact that my redirect URL was not HTTPS like caused pretty much everything in existence to refuse to service the request unless you explicitly, like, again, some didn't support this, but some said basically allow insecure or something, and it would allow you to do that, which technically breaks the protocol. You're not supposed to do that, but whatever. It works. It works for this specific use case. It makes sense. Let's see, Okta creds. So it's pretty straightforward here. It just reads the credentials from the file. There we go, right there. It attempts to assume this role. You can see the privilege role I commented out, so the access keys I wasn't spitting out on the monitor and recording for everyone around weren't actually like admin keys to this account. But yeah, it attempts to assume the role. If it fails because the token's expired, token, which pulls the token endpoint out of the configuration. It constructs a new set of parameters, including a refresh token grant type, specifies the refresh token that it had on hand, and let's see, and then it makes the request, writes the new data out, turns the new data, and then it loops, and it just tries it again. So pretty straightforward. There's where it writes out the data that the AWS tools expect: access key, secret key, session token, expiration, and version 1. Writes the cache out to the file, dumps it to standard out. So this was, I think, let's see. There we go. Converged, and then AWS, STS, call it right in. And authenticated to AWS with my Okta OAuth credentials. So that was the sort of the CLI use case. And again, one of my goals is to unify our authentication to using Okta with OAuth so that the mechanism is basically the same everywhere. This was for the CLI tools, but for this demo, I also I don't know what time it is or how long I'm supposed to go or not go. Okay, 8 o'clock. All right. So I'm not going to go into Chalice. Chalice is just a little micro framework modeled after Flask that allows you to write, again, Flask-looking APIs in AWS using Lambda and API Gateway. I used it just because I thought it would be an easy way to like make something simple. I'm not sure that I would recommend Chalice after this little project, however. It has problems. But just to show you what it's like, here's the actual like app. So it looks like, just like Flask. You set routes. tell it like what to return. What I additionally did is I made this authorized decorator. You can optionally specify claims. It will verify that the claims are in the token. It'll return a 401 unauthorized if it's not. This route, I put a claim that I actually don't have in my token. This one, it doesn't verify any claims in the token. It just makes sure the token is valid in general. And it also prints out my email address. So, it's for single sign-on. So I wanted it to actually know who I was. And this last one is an endpoint that for a claim that I do have listed in my token. I wanted to take some time to actually go through some of this, but it's probably not going to happen now. But basically, it looks for the authorization header. It pulls the token out of that here. Then, let's see, get claims. So it gets the token. It gets the keys from the endpoint. It caches those keys, so it's not retrieving the keys on every request. It parses the token, which, again, does the token validation. And then it returns the rest of the token's claims. Here you can see it pulls the key. It verifies that the key signed the token, and that's about all it does. I won't worry about get keys. That's just standard kind of stuff. So authorized bearer gets the claims. If it doesn't return anything, it's unauthorized. And then it checks that the issuer is my Okta issuer. That's if you read up on how you're supposed to verify a token, these are what you do. My JOT library actually verifies the expiration time, so I don't need to do that. But it checks the issuer, checks the audience. If there were no additional claims that I requested, it returns. Otherwise, it loops through the claims, and it actually uses some set math to determine if the list of claims in the token is a subset of the claims that I requested. And if it's not, it's unauthorized. Otherwise, it allows it. So I already have this up and running, I believe, but I'll just run it one more time just in case. And then because this is a Python meetup, and also because I don't really know JavaScript that well, I wrote a web client in Python that will run on localhost and interface with this API. Come on. I'm guessing it's uploading the zip file. I don't think it's huge, but it might be enough that this will. Yeah, the connection might be kind of. Yeah, while it's doing that, that's really small. I think that's the same number of font size increases. I just use Bootstrap because it seemed like maybe I should. I don't know. I'm not a web developer, so don't hold that against me right now. Okay, I'm pretty sure that I don't need to do. I'm pretty sure it's running still, but you know what? I'm now afraid to actually cancel this, just in case. But anyway, so this is just a front end that I put on that hit all 4 of those endpoints. Again, the unauthenticated endpoint doesn't require token. It returns what you'd expect. All these others require a token of some kind, so they get the unauthorized bits. So I click my little login button. I'm still signed in, so you're not actually going to see the redirect. It's going to refresh the page with open. In just a minute. There we go. So pulled that out of my token. Again, I'm missing claims that are needed for this one, so I'm still unauthorized. This is the one where I had claims. I had the required claims, so I got the right response. And this is the one where it just parses your token and figures out who you are. That's Intel. That's about it for my demo. If there's any questions or anyone wants to see the code or repos or whatever, we can let me know, or you can talk to me after this or whatever. But are there any questions now? All right, sorry, I went a little bit long, so. Well, we didn't go over time, but I try to stay well away from the 8 o'clock time. An hour and a half feels like a long presentation, so.
Thanks.
Sure.